Hello, everyone. I wanted to make a quick video to help you with graphing a type of rational function that we didn't get to in class. So we did one from Alex where we had holes, and you could see how to find, you need to find your holes, your vertical asymptotes, your x-intercepts, and then use your end behavior fraction to find your horizontal and slant asymptotes. And then you'll put all of that on your graph, and then you may need to choose extra x values so that you have 2 points on either side of each of your horizontal asymptotes. Usually you'll just have one, so you just have to make sure you have 2 points on either side of your vertical asymptote so that the function, so that Alex can use that to connect the dots, and that's going to help you as well. So I wanted to go through this number one here in our notes. I want to go through something that looks like this. W of x equals 2x squared plus 8x plus 3 all over x plus 1. So to graph a rational function, we're going to start by finding our holes, x-intercepts, and vertical asymptotes. And to do that, we need to factor everything. So we're going to start looking at this numerator. And to factor it, we need to find magic numbers that multiply to whatever a times c is. And again, that's in ax squared plus bx plus c. That's where I'm getting my a, b, and c from here. So in our function, our a times c is 2 times 3, which is a positive 6. And those same two magic numbers need to add to whatever my b value is. Here, my b value is 8. So I need two numbers that multiply to 6 and add to 8. Well, let's think of numbers that multiply to 6. So to multiply to 6, I have 6 and 1. I have 2 times 3. And that's really all that multiplies to 6. Can I get 8 with any pairs that multiply to 6? I can't. Those magic numbers don't exist. This thing is not factorable. Okay, so I can't turn this into thing 1 times thing 2. So this is as far as we can go. My original is as far as we can go with factoring. I can't factor the numerator. I can't factor the denominator. So this is what we've got. So do we have anything that's the same on the top and the bottom? It would cancel. Nope, we sure don't. So what that means is that we have no holes. Okay, so we don't have any holes. Now we're going to look at x-intercepts and vertical asymptotes. So remember, the x-intercepts happen where the numerator is equal to 0. So that's going to be 2x squared plus 8x plus 3. It's going to be wherever that equals 0. To find the zeros of that, you would want to factor this, but again, we already know that it's not factorable. If you really wanted to find your x-intercepts, you could do that. You could simplify this or solve this with the quadratic formula, right? The x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. You could absolutely do that and find your x-intercepts. But frankly, barf, like that's a lot of work and it's a lot of opportunities for mistakes. I don't want to do that. I'm not going to bother with this. So for now, I'm not going to find the x-intercepts. No thanks. It's not worth it here. So let's move to our vertical asymptotes. The vertical asymptotes happen where that denominator is equal to 0. I'm going to subtract 1 from both sides, which means x equals -1 is my vertical asymptote. Okay, great. Now I just need to find horizontal or slant asymptotes. To do that, I'm going to look at my end behavior fraction, which is the leading term of the top, over the leading term of the bottom. And I'm going to take that from the simplified version, which again is our original because we don't have any simplifying to do. So my leading term on top, the biggest bully on that top playground, is 2x squared. That has the highest power of x. And the biggest bully on that bottom playground is x. That's the highest power of x in my denominator. Let's simplify this. 2x squared over x that simplifies to 2x, which means at the ends of my graph, my function looks like y equals 2x. That's a slanted line, which means this thing has a slant asymptote. Okay, so I have a slant asymptote. Okay, do you remember how we find slant asymptotes? That's right, we're going to get to do polynomial long division. So I'm going to take the top, 2x squared plus 8x plus 3, and I'm going to divide by that denominator, which is x plus 1. Okay, let's do polynomial long division. So the thing on the top, I'm going to take the leading term on the inside over the leading term on the outside. That's how we do this. So I'm going to do the leading term inside is 2x squared divided by my leading term outside is x. 2x squared divided by x is 2x, right? That's what we got here. That's always going to happen. So now that I have that, I'm going to take that 2x and I'm going to multiply by my entire divisor. So I'm going to take 2x times x plus 1, and I'm going to put that multiplication down here. So I'm going to do 2x times x is 2x squared, so I'm going to put that under my x squareds. 2x times 1 is 2x, so I'm going to put that under my x's. And I'm going to subtract this whole thing. 2x squared minus 2x squared, those cancel, which is exactly what should happen. And then I'm going to take 8x minus 2x, and I'm going to get 6x plus 3. Okay, now we got to do this process over again. My leading term inside is 6x. There we go. My leading term inside is 6x. My leading term outside is x. So 6x divided by x is 6. So I'm going to do a 6 up here. And then I'm going to take that and I'm going to multiply by my whole divisor just like before. So I'm going to do 6 times x plus 1, and I'm going to put that down here. 6 times x is 6x. I'll put that under my x's. 6 times 1 is 6. I'm going to put that under my numbers. Oops, sorry, I forgot to switch back to blue. And then I'm going to subtract that whole thing. 6x minus 6x, that cancels, which tells us we are doing great. 3 minus 6 gives me a -3. And -3, my leading term inside, over x, my leading term outside, that's not a whole number. We are done, which means my slant asymptote has the equation y equals 2x plus 6. So if I'm putting this on a graph, I'm going to start putting all of these things on here. I'm going to start with my asymptotes. I have a vertical asymptote at x equals -1. So there is my vertical asymptote. I have a slant asymptote at 2x plus 6. So I'm going to come up to a y-intercept of 6. 1, 2, 3, 4, 5, 6. And I'm going to use a slope of 2 over 1. I'm going to rise 2, run 1 to get another point. And similarly, I can come down 2 and over 1, and I'm going to dot in my slant asymptote. Pretend that's a straight line. I have to kind of use your imagination. My scale's not perfect, so sorry about that. Okay, so there's my slant asymptote. Now, normally if we had x-intercepts that were nice, I could use my x-intercepts to put points on here, but I don't have any. If we had holes, I could put my hole on here for a point, but I don't have any. So to finish this graph, I need to choose 2 x values on either side of my vertical asymptote and plug them in. You can choose anything you want. So for extra points, I'm going to choose, let's see, how about, oh, sorry. I'm just going to try to find my notes that I already have written out so that this could be quick for you, because I'm assuming you guys can put these into your calculators. So let me just look and see the extra points that I had found before. I used x equals 0 and x equals 1 for the things on the right side of my x-intercept. And for the points on the left side, I used x equals -2 and x equals -3. To find your y value, you're going to plug your x value into this lovely thing and kind of fight through the arithmetic. I'm going to let you guys figure that out. I'm 100% sure that you can do that. So you're just going to plug 0 in and get 2 times 0 squared plus 8 times 0 plus 3 all over 0 plus 1, and you will get y equals 3. When you take x equals 1 and plug it into x everywhere here and simplify, you're going to get y equals 13 over 2 or 7.5, whatever you like if you're team fraction or team decimal. If you take -2 and plug it into your function, you're going to get y equals 5. And if you take -3 and plug it into your function, you are going to get y equals 3 over 2 or 1.5. And so we can put these on our graph. At x equals 0, I'm up here at 3. At x equals 1, I'm up at 7.5. So let's see, 1, 2, 3, 4, 5, 6, 7.5. I would be, again, my scale is not quite right here, and I'm sorry about that, but I'm going to be up here really close to that, that asymptote, but I'm going to be underneath it. I know that kind of looks like it's on top of it, but that's because my scale is not perfect. So it will be underneath that asymptote, and I'm sorry that that's not perfect. And then for my other ones, x equals -2 is over here. At -2, I'm up at 1, 2, 3, 4, 5. And at -3 over here somewhere, I am at 1.5. So 1.5 is like here. And then from here, I'm going to start at 1 point, go to the next one and connect it, continue through the point and go to your asymptote. And then I'm going to reverse that. I'm going to start at this point, connect it to the other point, go through it, and go to your asymptote. And again, I'm going to follow that process here. Start at 1 point, connect it to the other, go through it, and go to your asymptote, and reverse it. Start at this point, come back to this one, go through it, and go to your asymptote. So this is what my function looks like. Okay, so that's how you're going to do these when the top doesn't factor. So if the top doesn't factor, don't panic. I want you to find your vertical asymptotes and then find your end behavior fraction to figure out if you have a slant or a horizontal asymptote. Put everything on a graph and then find those extra points. I hope that helps. Let me know if you have any questions, and I will see you next time.